So JP and I are back in here. This is the same day we did part 2, and then we had some training and a demo with some folks in Canada. So now we're back with you guys, and we are filming part 3, the last on the 9S overhead site that we did, which is the second site that we've done. So we'll be so today, that's when you're watching this, you'll be watching part 3 of the 9S. And then for June 1st, we don't have a webinar for Memorial Day. So we're taking a little break there, and then we'll go right back into it starting June 8th. Okay, so you know that we've got the new ways to learn or do demos. You can just give us a holler, and we'll set it up for you like we have a lot of other people. It's been a great way to reach out to folks in this crazy time. So we've been able to do both demos and training. So if you just say, hey, we'd like training on a 4S and a 6S meter today, that's what we can do. We can just train you on 4S's and 6S's, however you want to do it. You can also increase the size of the screen and cut out the chat room, or you can hit that HD in the bottom right-hand corner right next to those arrows, and you can get rid of the video, audio, or lagging if you have that going on. So this one's going to be, we'll go over a quick review, talk about leading up to this last part of it, equipment check and maintenance, high voltage probe placement, testing CTs, why recall the data, and harmonics. So we'll be going over all that. So this is kind of cool. Before we get rolling, I'll be praying ahead to what will be happening a week from now. So I'll go ahead and say a quick prayer and we'll get rolling. Precious Heavenly Father, thank you so much for this time today. And Father, I just, as far as with me, I just hope that for the rest of my life I can get more in tune with and understand, or try to understand and to appreciate how much you love us, Lord. You love all of us, every single person, sinner, not sinner. You love everybody, and love us so much that you had your Son die on the cross for us so that we could have repentance, so that we could have guilt, so we could have this this whole idea of being forgiveness, of the forgiveness of sins, and then spending eternity in heaven. So none of this is made possible without the death of Jesus and the resurrection of Jesus. So thankful for what he did. Trying to be appreciative of it for the rest of my life, and I know you only did it out of love. So even some of these things that seem bad in my pea brain that are going on, one day it'll all be made aware to me of why, and because you don't make mistakes, Lord. So thank you so much for this day today. Thank you so much. I'll be up there traveling in the Northeast while this is going on. So be with me on my all these other folks in our industry that watch us, Father, just get them home to their families. So all of these things I ask and I say according to the will of the one who paid it all, my brother, Jesus Christ. Amen. Okay, so that's what we're going to do today. There's the agenda. So leading up to this, talking about this site, this 9S site we went to, we showed up, we did our inspection, we looked at the pole, looked the conduits on the pole, transformers top of the pole, and we did notice some washout at the base of the pole. We did notice that there was some arcing in the back of the meter can. Looked like they had probably changed out the test switch in there because it was different than the ones we had seen earlier. So we've got that going on. It looked like our secondary current was up though. We had like a 2 amps of secondary current, which means we should be able to test it pretty easily. We know that we have, when we get low secondary current on, it's tough to test those CTs, isn't it? So you start seeing less than a half an amp, it's going to be tough to test them. We didn't see anything crazy on the vectors so far. Didn't see any polarity reversal or cross phasing or anything that really jumped out at us. We didn't see any one of them being way less than the others, which could be indicative of problems lengthwise on the vectors. We didn't have 2 of them one length and one of them a lot shorter for some reason. That can be any of a number of problems maybe. So far so good. We didn't like the size of the angles between the vectors on each phase, which lets you know about polarity reversal if it's really bad, 180. But also if it's just a wider angle, it lets you know if you're losing more money because of that bad power factor, right? Bigger the angle between the current and the vector and the voltage vectors on that same phase, the larger the angle between the two vectors, voltage and current on the same phase, worse the power factor. And by worse, we mean a smaller number. One's perfect. If we multiply by 1, we get everything, don't lose anything, right? As we start multiplying by smaller numbers, we're losing a percentage right off the top. For instance, if you multiply by 0.75, you're taking 3/4 of something, you're losing a quarter. So you'd be losing 25% right off the top, so that's not good. So we noticed our vectors were kind of big on each of the 3 phases. We didn't like that. We also understood it was a heavy motor load going on in there. Probably had some drives and things going on as well. So we would probably expect to see harmonics, and we'll take a peek at harmonics on this site. That's what we're leading into here. We tested the meter, and the meter tested out okay. It tested out at 100.013, something like that anyway. So that means if it's over 100%, that the power company's making out just a tiny bit on that, more than dead 100. Less than, then the power company's losing a tiny bit. We want to keep it at tiny. That's why we do all this testing. So that's kind of where we are right now. So we're ready to start into it. We're going to start finishing up the test. We're going to test the CTs and take a look at those. And so let's and you'll notice here, and I'll get JP to stop it. We run into something with the high volt probe. That's another good thing, a good chance for training. So we'll go ahead and get started. So Brown's getting his stick ready to go. So by the end of the time we were testing yesterday, Browlin noticed, and this is another, any tips that we can give or any training we can give, we obviously always do it. So we noticed that on the time delay on the high volt probe, normally you can set it for the longer delay so it'll stay powered up before it turns off. In this case, we noticed that it wasn't staying on as long as it started shutting down a little earlier, which was giving us an indication that the battery might be going down on it. So Browlin's going in here, he's going to change the battery out. There's a 9-volt battery, just your typical straight 9-volt battery. There's one in both base unit, the back of the base unit, and in the back of the head unit right here. We make them so that they got their own battery sources right here, 9 volts. But the problem is, you got to be careful. If it gets below 8.8, has been my experience out there in the field. Once it gets below 8.8, I've had folks call in and tell me, man, I'm starting to get some crazy readings on my high volt probe. It will actually, if the battery gets low, you will start to see some, typically for me anyway, it's been typically high ratio errors. So you'll get some real high ratio errors that start giving you some funny numbers. That's what will happen if your battery starts getting low in this thing. And it doesn't like it once it gets below 8.8. Typically I've tested new ones and they're like 9.2 actually. But once they get below 8.8, you can start having issues. So we're just going to go ahead and change them out. You can see how we'll let JP get in here. You can see where he takes the cover off the back right here, and that 9-volt battery just sits there. Now I will say, and Browlin knows this too, you got to be careful because you got some little bitty small wires right there, right, Browlin?
Yes.
And the way that it's a snap-on top on here. I'm going to let him do it. So if he breaks it, I'm not going to get blamed for it. So you got to be careful. You will pull those 2 little small wires loose pretty easy. So just be careful when you're doing it. Just kind of take your time there. And I wouldn't recommend pulling off, and we'll get it out here so you can see it. And you tell me if this is the way you think about it, Brown. I don't like pulling that off. I'd rather just pry it off to where I don't. Because if you pull on that thing and jerk very much at all, once it pulls free and pulls loose, you tend to jerk, and that one jerk can bust one of those little small wires. I'll be honest about it, the first time I did it, I broke one of the wires. So I can tell you that it will happen because yours truly has done it. Dude, did I just hit the mic like that? That's going to be a loud thump, isn't it? All right. So, okay. Yeah, this high volt probe definitely does not like it if that battery gets low on it, okay? And you'll start seeing, as I said, you'll start seeing some crazy numbers come up there. You'll start seeing 15, 20% ratio errors. You're like, whoa, what's going on? And just stop and think about the battery. We have these batteries in here, but now it's supposed to shut off, okay? So there are different, let me go grab this base unit. This is the older style that has the window on it. The newer styles from SensorLink, they don't have that anymore. They took that off there, but they upped the rating on the high volt probe. So the rating's higher on it. I believe it's 430 kV phase to phase now. So you got to watch. It doesn't have this on here anymore, so it's just kind of an indicator light of giving you, green or green flashing that it's talking, communicating, and green if it's charged up, red if it's not charged. So, but it's got 9-volt batteries in the back of here. But there was delays that you could set on here if it had the screened one, and when you first turned it on and hit the base unit like that and turned it on, when you hit the head unit, and unfortunately here's where you changed it, when you hit the head unit it would have a 0 and a decimal point. That was the shorter delay. You could hit it again and the decimal point goes away and you get the longer delay on it, because you want to get up there and get your test done before it shuts everything down, because it's going to shut it down to save those 9-volt batteries, right? Well, you want the longer delay when you're out there working, because you don't want to have it shut down before you're finished with the test, okay? But that's when you change these out, be extra careful with those little wires, man. I'm telling y'all, if you try and pull that loose, you think, oh, I'll be really, really careful. You saw they're not long and they are not heavy wires, so you can pull them loose really easily. Go ahead, JP. So just change her out, put her back in there, and now we know we're good to go. Guess we're going to be real anal about it. We test the battery first before we put it in there on the new battery, because it has been sitting in there a long time. And I'm sure they're still good. Yeah, I noticed the number for me, anything less than 8.8, then you could start getting issues with it. So I just want to make sure it's 8.8 or better. So I would say if you haven't used it in a long time, or if you've used it a lot, either one, just every once in a while you might just want to check these batteries real quick. Just get your meter and check them real quick and see what kind of voltage you got on them. Because if it's below 8.8, like I said, you could have some issues with it. All right? Like we're spoiling him here. This is going to be an easy one compared to some of the ones we've given him this week. He should be able to get up on there pretty easy. Now, when you look at this, where are you wanting to get on there, Brylan? Where you want to try, and where would you pick your spot? Because you kind of assess it first before you actually start sliding the pole up, right? And figure out where am I going in?
Yeah, I just look up there, I don't want the wires, I don't have to fight them. I want them to be close together.
Right.
I mean, if it's before the CT or after the CT, most of the time the fork, it's not really that, I mean, it is picky to an extent, but when it comes to before or after the CT, it doesn't really affect it that much.
No. It's mainly just getting a nice clean grab with that high volt probe around those conductors, right? Exactly. Whether it's before or after the CT, it really doesn't matter. You just want to make sure you get all the conductors in there. And honestly, too, another thing to consider is not getting extra things in there, a bunch of control wires and other stuff in there, right?
Correct.
So you want to try and make it clean and get just around what we want to measure, which is those right there. So he's got a good shot right there where he can get around those conductors. He's deep in there, so he's inside. Remember, you got lines on there, and you want to get below those lines, so you got a sweet spot in that high volt probe, which is in the bottom of it. So you notice that whenever he's doing it, Brylan always tries to bottom out that high volt probe, which puts you below that sweet spot. There are lines across there on that high volt probe, and you want to be below them on those forks. Okay. And if he's so the lines that we're talking about there, these are these lines right here and here, right? So it comes across here. You want to be below that. So inside here is your sweet spot. Outside of it, accuracy gets worse. So you want to be right in here, below, like I said, below these two lines here, below here. You want to be in the sweet spot. That's why I always talk about bottoming it out. You notice that's exactly what Brylan did in that shot. He bottomed it out. Remember, label towards the load. All right, if you get it in the other way, it's going to give you polarity reversal. Also, you want to try and be perpendicular to the conductor. You don't want to be like this on the conductor. You want to be perpendicular to the conductor on it, okay? Not like this way and this way if you can help it. Okay, you want to try and be perpendicular to it. You want to have it bottomed out, and you want to go label towards the load. All right? Go ahead. If he's bottomed out, he knows he's definitely below there, and he's in the sweet spot. So we're going to go ahead and come over here. We're going to hit next test, which will take us to the CTs. And since it always shows us the color diagram, so it's going to show us that. And as we've said before, it's got a solid green circle for A, open green circles for B and C, just telling us you're going to have to move the probe to B and C. But you're good, you're connected on A with it, the probe. Just remember you're going to have to move it to B and to C right there. So we're going to go ahead and hit next. And it always tells you to move the probe to phase A
and press F6 to start the test. So our popular button F6, we're going to hit it. We're going to find out if we are on A phase.
Okay.
So
a few things going on here. First of all, you know that, by looking at this, I got a pass on it. So what that means is, if you think about it, I've got 3 phases up there, and I'm not sure which one's A, B, and C. B, middle, figure that one out. But it's A and C, I'm not sure. When he put that high volt probe up there, right, he put this on there, and he took a guess which one was A or C. If he would have gotten, if it would have clicked a couple times and then it would have popped up here and said cross phase connection, then that means the machine's looking for you to be on A phase and instead you're on C. So that means it's telling you you've got a cross phase connection. It's the same as if you'd taken that flex probe and wrapped C around A and A around C. So I know now I don't have C, I have A. I'm sorry, I don't have A, I have C. So I wanted to start out on A phase, so I'm actually on C phase. So what I can do is I can stop right then, and I can just go over it. It's going to fail that one, right? Then I can go over to, I can hit continue and fail. Then I can go to the other end, right? I can go in the middle there, and I can go B, and then I can come back and do C, and then I can go back and do A. Or I can just go from that one, I can go over to the other end, and I can hit retest and start over again. I got options. But I know that I'm on C phase instead of A phase. The machine's expecting me to start on A, either with the 1 or if I had all 3 on there. But either way, my probe that's connected to A phase is actually, it's on C. And in this case, you can use it to troubleshoot and figure out what phases you got up at the top, okay? I want to be inside of here. I want to be perpendicular, right, as much as I can. And I don't want to be up in the middle of a whole bunch of wires where I have other wires touching on the outside, maybe giving me some of that phase angle error, those issues. So I want to try and get this clean as possible. So that's what we were talking about when we said you don't have to get right in front of, right behind the CT. If you got to move out a little bit to get away from other stuff to make a cleaner read on this thing, then do it. Okay, to where I only have things inside of here and I don't have stuff on the outside touching, and I don't have extra stuff inside of here. I just want the conductors going through the CT. Either close to it or not close to it, just those conductors, okay?
couple of things. It tells me, yes, he is on A phase. I got a pass. It tells me that he has the fork oriented correctly, right? Label towards the load. So Brownland's got it correct. He's got label towards the load, so he's got that pointed in the right direction. He's got that label on the side going down, coming down to my customer over here, down the pole. So he got all that correct. And because he had all that, we didn't get a cross phase, that he was on the wrong phase. And we also didn't get polarity reversal, which meant he had his his probe the wrong way. He didn't have the label towards the load. So all of that was right, and since everything was correct that way, the load also measured well, so we only got 0.47 on our ratio error. So we got a pass here in green, so everything looks good. So now he's going to move over to phase B. It's telling me to move probe to phase B and press F6. So that's what we're going to do. You good to go?
Yep.
He's always ahead of me.
And if you hear the clicking in the background, that's where it's at. It's applying the burden, right? Because remember we talk about that. It's throwing those resistors in.
So we got a good
and it's applying the burden
good pass again, a good test on B phase. So we got a pass here. So it's, and notice that if it says 200.95 to, 200.94 to 5, and then 199.04 to 5, it's going to say my nameplate ratio is 200 to 5. So it's saying, okay, off of that, I'm going to say that my nameplate ratio is 200. So here we only have 0.48. So once again, we're great on our ratio error. It's low. And we've also, we don't have any problems with phase angle errors. So we're doing well there. So we're going to go on to C phase. And I don't even have to look because I know he's already on C phase because he's always ahead of me. So I'm going to go ahead and hit the button. So we got 3 passes right here. So this is what we like to see. We would consider this site good. We would say the meter tested fine. We would say that the CT's tested fine on this. So we would say that this would be a site that we've got a good test on. And just for grins and giggles, I'm going to say, okay, done. And if you wanted to take a quick look, how do you have this one entered in here, Brian? I'm going to do a recall data real quick. I'm going to go to number 7, recall data.
This one's going to be 9S demo.
Got a couple of them in there, huh?
Oh, there's a bunch of them in there. Might as well.
I'm just going to show them real quick. So if you go right there, 9S demo, and you go right here and go down one, this is today. We're down here doing our work, so we're going to hit expand because it's a Christmas tree diagram. So all it's doing, a tree diagram rather, Christmas tree diagram, so it opens up, so now we can see.
And you can see we talk about this when you go to recall data. If you go back to that screen real quick, JP, well, you can see right here. Never mind. You can see right here, if y'all can read it, okay, that underneath it's going to show the date from the testing session starts. Then under that, it's going to have the individual tests. So it's going to date and timestamp when you started the session, each of the individual tests. And then if you had, for instance, a phantom load test, there's 3 tests that comprise a phantom load, right? Full load, power factor, and light load. So then it would have another little plus next to it for you to open that up and expand that out to the 3 choices for a phantom load test. But here you can see the date and timestamp, and you can look at each individual one, okay?
Shot of that. But we also have here, we're going to look at the CT test. So we go right here.
And the last item right there, that power data one, is one that we just added, and that's one where we just hit stop and save because we wanted to look at the numbers on that. So you had the standard 2 tests that we did, but we also added something extra there, so you can add extra stuff in there. If you saw something you didn't like or was out a little bit and you wanted to note it and add it to the report and have it logged into the system and have it in there, you would just do what we did here, and that's when Browlin hit stop and save. So he added that one in there on his own manually. Those are the 2 that when we completed the test, it automatically saved them.
You just want to make sure and take a look at it before you leave the site to make sure you got everything. So we're going to hit exit, come down one, and take a look at our customer load test we did, which was 100.113. So there you go. So before you leave the site, it's just always a good recommendation to go ahead and take a look, hit a recall data real quick, make sure you didn't fat finger something or mess something up. For some reason it didn't capture something, because you'd sure hate to get down the road and get back to the shop and then find out you didn't capture it. So take a look at that recall data, and then once you take a look at that and we had a good test, it's on to the next one. One thing we wanted to point out here on the site that we're at is we don't talk about it a whole lot, Harmonics. And when we were listening to everything that was going on behind us, we said, well, maybe we'll just take a look at the Harmonics. So we wanted to kind of point that out. There's 3 different spots on the test equipment that you can see Harmonics. When you're over here, you can actually see it right here if you hit this hot button, which we did. This is the hot button showing RMS table. It just gives you information, right? So we're just going to hit this RMS table right here. And you can notice here, down here at the bottom, you see the current right there. It's getting up 12, 10. It's getting kind of high up there on the Harmonics on the current. The voltage, it doesn't, you know, I'm not seeing a number. Remember, it was V8. I've mentioned it before, V8. I remember it by the juice. I need something from my P-brain to remember it. So if it's over 8% on the voltage, it's bad. So we're not seeing that too much there. But let's take a look over here at if we look at graph form, you can see where my voltage and my current are getting up there pretty good here, right? But then let's take a look right here.
And remember, if you look at the top of the, bottom of that screen, you'll see stop, and you could hit stop and save. And since we're not in test mode right now, you could stop and save any of this that you wanted to and add it to there about the Harmonics. Go ahead.
Back in Knoxville, but you can see right here, you see the choppiness on those waves? Normally when you see choppiness on those waves like that, that would be indicative of Harmonics, right? So we know there's some Harmonics going on in here, and you can hear what's going on behind us. So we talk about that in the class, but I wanted you to just see it out in the field. This would be a site that we would know. Just keep it in mind of potential, maybe a cause of a problem. Just remember they got a good bit of Harmonics going on behind us with that noise that you hear, all right? So there are 3 places that you can look at it. You can look at it on the RMS table as a number value. You can look at choppiness on the waves, or you can see it on the bar graph. So there's 3 different ways to look at those harmonics. And it would just be something to note. And if you wanted to, as Brownland has mentioned before, you could hit stop and save and capture those and just have them in the file with it, or have it so that it would be attached to that site to just keep that in mind. If there was any potential problems or any damage of any equipment moving forward, you would say, well, wait a minute, we did note that there was some harmonics on this site, so it's just a good thing to keep in mind.
So we had, so if you looked at the site, on our initial investigation, we had some washout of the pole, had a flash burn inside the meter can. The top didn't look super bad, nothing crazy there. When we tested the site out, noting what kind of a customer it was, at one time it was a pipe fab place. Now it's got a bunch of motors in there, saws, and they're cutting, and they got controllers on them, and they're cutting granite, so you could hear them in the background. So we had a lot of inductance, which makes the angles worse and a worse power factor. So we saw that. So we had didn't have great power factors there. Had some pretty big angles on all 3 phases. We also, when we went to test it out, though, we had good load on it. It wasn't like there was too low a load. Sometimes you worry about it. If you think about this, you worry about when you change the customers at a site and you don't change CTs, and you and I fight that all the time, don't we? Used to be 800 to 5s. The customer was enough there that 800 to 5s are warranted. Now another customer comes in and they don't have nearly the load the previous one did, but we didn't change those 800 to 5 CTs. So now that we're way on that back end, that light end, aren't we, to try and test them? So it's already kind of put us in the curveball because they didn't change those CTs out. So you got a very, very low load on. You should have at least 80 amps on those 800 to 5s according to ANSI to test them. So then you get in there and you just got some lights in there or whatever it is, and you don't have nearly 80 amps. Well, now you're already behind the curve, you know. So it's just stuff that we have to deal with all the time being out there doing our testing, right? So you just got to use these and this as much as possible. When something doesn't look right, you know, I just heard a guy not long ago say he goes in there thinking there's something wrong at every one of them, and it has to prove him wrong that it's right, if you think about it. So he's saying, I'm going there expecting to find something wrong, and this place has to prove me that everything's okay. You know, it's whatever your attitude is. If you just keep these open and think about it, a lot of this stuff we can work out, and we start developing those good habits and good practices and get those Rolodexes going in our head, and we can come up with some good solutions. And we're so valuable to that power company, being the eyes and ears for them on a continuous basis out there. So good luck to y'all out there. Be careful out there. And please send in what you'd like to see on the next one, because we're not going to have one. We're going to have one next week. Is the one we just did here. So we've done this one, but now I'm going to remember we're going ahead a week. So the following week we're not going to be here. We're not going to have one. So I'm not weeks live, but you guys come up with some, give us some suggestions on whether you want a 3, a 4, a 5, or a 6, and whether you want overhead or underground. I'm sorry, and we also have the pad mount 9. So we got pad mount 9, then a 3, 4, 5, or 6, either overhead or pad mount. All right? Send in what you want to see, and whatever is the most popular one, that's the one JP and I'll do the next one. And God bless y'all. Be careful out there, all right? Bye.